we are going to do some log questions. If you see on the right corner here, I've written down some log rules. If you don't have it written down already, maybe you should copy it down, pause the video and copy it down, or take a screenshot so you have it there. You should be familiar with most of these. Something that we've talked about but we haven't used extensively is the change of base formula here. And I'll give you a question to do with that as a challenge. These last two aren't exactly the log rules, but just good to know. All right, let's get started. So number one, express as a single logarithm. So I'm going to do that using the log rules. 4 log base 10 of p plus 2 log base 10 of q. Remember that if there's nothing written as a base, that's base 10. So I see that I can use this log rule here because the m is multiplied in front and it's going to go as the exponent of x, right? So then I can write these as log base 10 of p to the 4th plus log base 10 of q squared. And then I'm going to use the first log rule here and combine them. And that would be log base 10 of p to the 4th times q squared. All right. Yeah, easy. All right, next question. 1c. We have 3 ln of x minus 2 minus 1/2 ln of x. So if you don't remember, note log base e of x is written as natural log of x. So there, it's just log base e. So the same rules, same log rules apply there, so we can do that. At this point, I want you to pause the video and try this out and see if you can get it and do it on your own. All right, welcome back. So 3 is going to go as an exponent of x minus 2. Right, here you have to be careful. There's a difference between that. In this case, only the x minus 2 is being cubed. If you want the entire thing to be cubed, you have to write it differently. You have to write it this way. Okay, so, all right. And then moving on, and 1/2 ln x, and 1/2 is going to be the exponent, so I'm going to write ln of x to the 1/2. Remembering our exponent rules, I know that x to the 1/2 is square root of x, and I'm going to write that as a square root of x while combining it and do it all together. Maybe I'll just do it one step at a time here. There. And then I'm going to combine these. Oops. I get natural log of x minus 2 cubed over square root of x. Okay, so try the two questions highlighted in blue. So number 1E and F. It's going to show up as a quiz question right now, but I won't give you the answers right away. And I'll put that at the very end of the video so that if you need to watch it, you can watch it. If you don't need to watch it, then you don't have to. Okay? Number 2A. Natural log of x to the x over x minus 1. I'm going to use a log rule to split them up. That would be ln of x minus ln of x minus 1. And I know that, well, that's a, and this is b. So I can write it as a minus b. Number 2, b. Natural log of x squared minus x. Right, so I think I can factor out an x there. So let's see, x, and then it'll be x minus 1 there. So it's going to be x times x minus 1, so I can split that up using the first log rule, and you get natural log of x plus natural log of x minus 1, and that will be a plus b. All right, so here again, I want to remind you to pause the video and try this out. ln of 3 times x squared. So this is a really good chance for you to see if you can do these questions with zero pressure, right? Try this out, pause the video, try it out, and then when you press play again, I'll solve it for you. All right, so welcome back. We have we have ln of 3 times x squared. So I'm going to split them up using the log rule. Ln of 3 plus ln of x squared. And then using the log rules again with this ln of x squared, bring in this square to the front. There you go. Then I know that ln of 3 is c, and then ln of x is a. So c plus 2a. The question that I want you to try is this one, but you are also going to use a change of base formula, which we haven't done a lot. We've proved this in class, but we haven't used it to solve problems before. So the way you use this is you have the log base a of b, but you can use whatever base you want. As long as c is positive, you can use whatever number you want and change it like this. So log base c of b, that b goes there, and then log base c of a. The base of the original log becomes the argument for this the log in the denominator. All right. A lot of times you can technically choose whatever base you want, but if you're trying to do certain things, if you're trying to be clever about it, you would maybe use c to be equal to a or b. That way one of them will cancel out, become 1. Maybe this will cancel out, become 1 if you chose c equal to a. Or in this question, you know log base 5 of 6 and log base 5 of 11 as a and b. So if you're going to use this expression, and you need to change it, maybe you should change it to log base 5, right? Because you know what those are. So that's my hint, and try that out. And again, the answer will be at the very end of the video. All right, the next question here is using the log rules and then describing the transformation. So I'll do the second one here, the one highlighted in green. So h of x equals log base 2 of x plus 3 squared, and I'm going to use a log rule to write it as 2 times log base 2 of x plus 3. So what is this 2 doing to the curve y equals log base 2 of x? Well, that's going to be the vertical stretch by a factor of 2. Vertical stretch by a factor of 2. And what is the plus 3 doing here? This plus 3 is moving the graph, shifting it to the left 3 units. Shift to the left 3 units. You can use translation, but horizontal translation to the left by 3 units is a little bit longer than shift to the left by 3 units. So I'm going to write it this way. Your choice. All right, now I want you to try 4ai and describe the transformation there. Okay, next we're going to solve some equations. Now the first equation involves exponential equations. Even though the bases are different, I know that 4 can be written with a base of 2. It's 2 squared. So if you see something like that, you can solve these. So the idea here is to change the right side and change 4 as 2 squared, like so. All right, then using the exponent rules, instead of writing as 2 to the 2 squared to the 2x power, I'm going to rewrite that as 2 to the 4x. Multiply those. Okay, now if 2 to the x plus 1 is equal to 2 to the 4x, the only way that could happen is if x plus 1 is equal to 4x. So I can say, oh, x plus 1 is equal to 4x. That means subtracting x from both sides, I get 1 is 3x, and therefore x is 1/3. Yeah, and then normally, you should try to substitute it back into the original equation, and see if that works. I'm going to let you do that and try the second question. It's very similar, and you should be able to solve for x, no problem. Next, now this looks very strange, maybe you have never seen anything like this before, but if I change it a little bit, you will recognize it as something that you've done before. So instead of 2 to the 2x, I can write it this way, 2 to the x squared. And this is going to be 7 times 2 to the x plus 6 equals 0. Now, do you see it? Maybe, maybe not. Okay, I'll try another thing. If you haven't noticed, I'm gonna let a equal to 2 to the x. Then I can rewrite the equation that I wrote above as a squared minus 7 times a plus 6. Now you probably see it as a quadratic, right? A squared minus 7a plus 6 equals 0. Okay, that's a quadratic. So you can factorize it or use a quadratic formula to solve it. This is factorable, so I'm going to factorize and solve. So I can write a minus 6 times a minus 1 is equal to 0. At this point, I can replace it back to the 2 to the x. So I'm going to do that. 2 to the x minus 6 and 2 to the x minus 1 equals 0. Now, if you saw this from up here, you saw that, oh, that's a quadratic, I can just go straight there. Great. You don't have to write the middle step. The stuff in blue is just here to help you. If I were solving it on my own, I would just go straight from here to here. Okay, and then if you multiply through two things and you get 0 as a product, then that means either one of the factors is 0, right? So either 2 to the x minus 6 is 0, which means 2 to the x power is 6. And solving for x, you can change it to a log form, which gives you x is equal to log base 2 of 6. And that's the exact question. You can put in the calculator and get a decimal answer as well if you want. And here you get 2 to the x minus 1 is 0. That means 2 to the x is 1. And you can also use a log form of this, but you know the answer is going to be 0, right? So x equals log base 2 of 1, which is just 0. Cool. All right, so that's what you can do. So those are your solutions. X could be log base 2 of 6, or it could be 0, and that'll work. All right, let's try the next question here. 4 to the 2x minus 10 times 4 to the x plus 24 is equal to 0. It's going to be very similar to what I've done on the left side. All right, here's a challenge question of the day, and lucky for you, it's a multiple choice question. Given that 2 to the 10th power is 1024, which is approximately 1000, which of the following is closest to being true? So you have those 4 choices. Work it out. This might take a while. It's not as straightforward as some of the other questions that we've done today, but I don't know, do the best you can, and again, at the end of the video, you can find the answer to that. Okay, so let's go over the answers. 1f is easier, so I'll do that first. I'm going to combine them, but first, it's going to be ln of x to the 4th plus ln of x minus 1 squared. Now I can combine them. Like that. All right, so that's done. Here, 1e, I need to combine 1 with ln of x. So if I want to use a log rule, the 1 has to change in some form of a log. And because the right side here is natural log of x, so I need to make 1 in terms of natural log. So I can write 1 as natural log of e. Because remember, natural log of x is log base e of x. So if I write natural log of e, that's 1. And then I can write this as natural log of x, and I get natural log of e over x. There you go. Next, oh, this is a very nice question. I like it. Okay, so let log base 5 of 6 equals A, and log base 5 of 11 equals B, and then write log base 6 of 55 in terms of A and B. So I told you earlier that we are going to use a log change of base formula, and so here, a lot of times when you're doing this, you change C so that you would cancel out one of them, either the numerator or the denominator, and they become 1. But in this case, because we have these two expressions in terms of log base 5, I should do that. And I'm going to write this as log base 5 of 55 over log base 5 of 6. So I am using the change of base formula, and what you notice here is that I already have the denominator, that's A, right? And then I don't know how 55 is going to happen with 6 and 11, but luckily I don't need to, because I can just write this as 5 times 11, and you can already change this as A, but I'll just leave it. Okay, and then in the numerator you can say, oh, that's log base 5 of 5 plus log base 5 of 11 over log base 5 of 6. Now I know that log base 5 of 5 is 1. That's 1. And this is B and this is A. So there you go. I am done. I got 1 plus B over A. Cool. All right. Next one was rewriting this equation and describing the transformation from log base 2 of x. All right. So use a log rule to split those up. So log base 2 of 8 minus log base 2 of x. And log base 2 of 8, well, that's 3, but maybe you can write this as 8 as 2/3, and maybe that's more obvious that way then. Okay, so there you go. So g of x can be written as 3 minus log base 2 of x. Maybe this is confusing because the 3 is in front, so you can just rewrite it if you want. Like so. So what is this negative sign doing in front? What is that going to do to my function? That's going to reflect the graph over the x-axis. And then what is a plus 3 doing? Here. Now earlier plus 3 moved it to the left, but this time it's outside of the function, so there's a little, maybe the bracket that I didn't write. So plus 3 is on the outside of the function, so that means it's going to move up 3 units. Shift up 3 units. There you go. All right, so here's the equation, and the trick again was to rewrite 9 as 3 squares. So 3 to the x plus 2 equals 3 squared to the power of 2x minus 2. And so this time you have to multiply 2 to 2x minus 2, so it'd be 4x minus 4. Did you mess it up there? Did you not distribute? Did you write it as 4x minus 2? Then you got a very strange answer, right? So here I can say that x plus 2 is equal to 4x minus 4. And then add 4 to both sides and subtract x from both sides. And therefore x is 2. All right. So here you can see that I can write this as 4 to the x squared minus 10 times 4 to the x plus 24 equals 0. And feel free to use another variable like a to rewrite it if you want. But I'm going to go ahead and write 4 to the x minus 6 times 4 to the x minus 4 equals 0. So that means either 4 to the x minus 6 is 0, which means 4 to the x is 6. And changing this to log form, I get x is equal to log base 4 of 6. That's one of my answers. And the other answer is 4 to the x minus 4 is 0. So x should be 1, right? 4 to the x equals 4. And if you insist on writing as a log form, it'd be like that, which is 1. All right. Oh, the question of the day, my favorite. This was really, really cool. So you are using approximation that 2 to the 10th is about 1,000. So if I say 2 to the 10th power is about 1,000, I shouldn't use an equal sign there. Yeah, roughly 1,000. Okay, so I'm gonna write that 1,000 maybe as 10 to the 3rd power. Okay, and then it sounds strange, but I'm gonna raise both to the 1/10th power. Okay, so then what does that look like? That's gonna be 2 is roughly 10 to the 3 over 10. Okay, so that means, okay, so this, if you change that to a log form, that means log base 10 of 2 is roughly 3 over 10, which is 0.3. So your answer is B. Okay, and that was it.